What is spatial information technology? Now, as the word suggests, it is an information technology which we are understanding and using to identify things on space. The word spatial means space. So, whenever we talk about geography, we see how things are located where they are. Why things are located where they are. What would be the benefit if these things are relocated to a new place? What would happen? Who would benefit out of it? Why the location needs to be changed? All these questions can be answered with simple concept of spatial information technology. So for this spatial information technology, the commonly used technology is GIS, which is Geographical Information System. Now, as we understand the spatial things that are distributed, the things that are distributed on the space, we understand that there are two parameters. One is the location on the space, the other is the attributes attached to it. So let me put it in a very simple example. Understand in this fashion that you are trying to apply or you are trying to get admission into a school. You are located into a city ABC. Now in that city ABC there are 100 schools. So what you can do easily is get a map of that city with the location of those 100 schools and identify based on your requirement whether the school is affiliated to CBSE or ICSE, how far the school is from your home, whether the school provides transportation facility or not, what is the duration of timing that a child would spend in each of the school, what are the co-curricular activities that the child would learn in the school. Now all these elements that I have told you are what? They are attribute data, they are non-spatial data. They have nothing to do with what is and where they are located, but a person who is trying to find a school in the vicinity, probably, let's say if I am trying to search a school, I would search a school probably in the vicinity of 2 kilometers. Now, if I have a mindset that I want to look for schools in 2 kilometer radii from my place of residence, what would be my priority? If on the map itself, I have the 10 schools probably which are near or within the radius of 2 kilometers, I have the visual outline. Okay, these 5 schools are CBSE based. These are the timings for these schools. Each of the school offer these co-curricular activities. It becomes much more spatial, much more informative, much more visual and much more easier to analyze. And that's where we have the basic utility for a spatial information technology. Now this image that we have captured here is an image from aerial photography, and from this aerial photography image we have marked the area X and then we have outlined another area which is this, and this is another area, let's say Y. So the word space, or what we understand from spatial, is the space component, and here we understand the features which are located here. So we can identify these are the residential complexes, these are let's say the grassland areas, these are the playground areas, this is probably aerodrome region. So we can identify various things based on the information that we get. Now, from this information, we understand the location, we understand whether there is agriculture, whether there is residence, whether there is industry. So this spatial information technology helps us in many ways. First of all, with the help of the technological inputs like aerial photography, remote sensing, we are able to capture data. Now, we are not only able to capture data, we are also able to understand the data with respect to time frame. So what was the number of residences, let's say in 1970s compared to 2020? How many residences have increased? How many industries have increased? Whether the forest area is declining or not. So all those could be obtained with a simple comparison of two different time frames, and this can be made easier with the help of spatial technology. Now, when I say spatial information technology, it's an amalgamation of GIS, which is Geographical Information Systems, GPS, Global Positioning Systems, Digital Cartography, Database Management Systems. So in this section, we would specifically focus on GIS. So simply put, GIS is nothing but capturing, storing, checking, integrating, analyzing and displaying the data finally in a visual format. And this visual format helps us understand and grasp the concept much more easier, much more smoother. So normally, if I give you a table, let's move back to the same example that we discussed. I give you a table with the name of the schools, their affiliations, their distances, their facilities, their co-curricular activities and all other phenomena. What would be the criteria? You would have a huge big table of 100 schools and you would be finding it difficult to analyze. With GIS, I can do a quick query and this query runs through a SQL, which we would understand in our later classes. The SQL query basically helps you to question schools in a radius of 2 kilometers away from my place of residence. So all the schools, you locate your residence place and all the schools from that region 2 kilometers in radius would be immediately identified. Then I can put another query where I can mark that this is the preferable school time that I require. These are the preferable co-curricular activities are required and so on and so forth, whatever your criterias are. And with each of those criterias, you would have quick query returns that would be seen. Now, I would have, let's say, 3 schools coming up for the first query, 5 schools coming in the second query, 3 schools coming in the next query. So what I can do is again amalgamate those data and see which school meets my maximum requirement, and based on that we can consider that school for application. Now let me put it into another simple example. Let's think about Walmart, one of the retail chains across the globe, predominantly in US, now planning to, let's say, have a step in India. Now when Walmart is planning to enter India, what Walmart would be identifying? Definitely it's a retail chain, so it needs footfall. Footfall will come when the people are located close to the region. So when Walmart is identifying, let's say, a location in Delhi or Bangalore or Hyderabad or Chennai or any other major city, they would identify what is the population density of the region, what kind of paying capacity is present in those regions, and based on that, the items they would have in the Walmart would be determined. If it is a low paying area, probably they would have cheaper items that would be more in the store. If it is a high paying area, the kind of items in their menu could change. So even the companies, when they are stepping into a new location, they are trying to bring in their products, bring in their services, they identify the market. And that is made much more simpler, much more easier through GIS. So these were just few of the examples that we cited. Definitely when it comes to land use pattern, when it comes to agricultural development, industrial establishment, all of those require GIS in one form or another. And this is much more methodological way of understanding, much more statistical, much more reliable, where you can use the attribute data as we call it, which cannot be actually represented on the space, but when the data is tied with the spatial data, it can be easily represented on the space, and this makes the concept much more easier, much more visual and much more simpler to identify and understand. So this is basically GIS. Now I am putting this again in very simple form. We usually identify features into 3 forms. Those are the point features, line features and area features. Point features can be, let's say, post office locations. It could be wells which are located in the village. It could be any individual shops or grocery stores that we identify in a location. So these are point locations. So I have an area of 20 kilometers by 20 kilometers that I am studying. Now in this area of 20 kilometer by 20 kilometer, I identify the grocery stores. These grocery stores would be what? These grocery stores would be point locations. Then I identify the routes. How you can reach those, if there is any shortcut, the long road, the roads that goes within the colonies or the highways that you have to catch in order to reach that location. So these are line features. The next is aerial features. Now aerial features could be probably the parking space available near the grocery stores. If it is a village area, I can identify those as agricultural units that are available. Now all these are aerial units. If it is an industry, I can identify the nearby water that is flowing and what area this is flowing. When I merge all these together on the 20 by 20 sketch of piece that I have, this is what is the final outcome. So I can now visually identify which location is located where. So as you can see on the first artery or the road, we have 4 grocery stores. On the second one, we have 2 of those. So this non-spatial data which was present with me, I have amalgamated that data with the spatial data, and this gives me a much more systematic, much more acceptable, much more conceptual format, and this is a format that could be easily understood even by a layman. A very simple example I would give again. In present scenario, we have COVID vaccination centers. Now, if I give you a whole list of 200 COVID vaccination centers in your city, you would keep searching. But if I give you a map with the 200 locations, you would identify, okay, I live close to this place and these are the nearest vaccination centers that I have. And this is made possible easily through GIS because the places where COVID vaccination is done has been mapped to the actual location on the ground. It could be the school, the hospital, the units where the administration is being done. And once it is mapped, I have the locations on the ground, which is visual, much more simpler even for a layman, a illiterate man to understand where I need to go and what path I need to follow. So the application of the area, the application of the budget, the application of the type of data. Now data can again be vector data, raster data that we would understand in a while. So all this information becomes much more easier. With GIS we have systematic use of scale, systematic use of symbols, colors, and a kind of coordinate system through which the location is mapped in order to understand the latitudes and the longitudes, and all this ultimately gives me the best of its kind of information. So what are the advantages of GIS? Now the advantages of GIS, first of all, we need to understand the limitations of the map before we understand the advantages of GIS. Map has limited information. I have an atlas with me. This atlas would show me the states of India, the various cities in India. But if I need to go further and dive further into each of the district, each of the city, that won't be possible in one atlas, so probably I'll have to search for another. Then if I have another atlas of a state, I want to see the city of another state, I need to have another atlas, and this makes the work much more tedious. However, with GIS, you have all the data stored in the computer system. I can put a quick query and find out the information for Odisha, I can find out the information for Rajasthan, Madhya Pradesh, and so on. Or any map which is predetermined to show specific characters and specific things only. If I need to know more about something else, that is practically not possible with the limited maps that we have. So therefore, GIS becomes advantageous. Now, I have the attribute data as I have already explained through the various examples, and the spatial location. The first basic thing is I can interrelate those things, and with the interrelation the things become much more systematic, much more smoother. Also, I can put the query. The queries are usually put as SQL, as we already mentioned. The next is how we can apply that spatial information to a new set of information. So let's say I have a very simple example for the same. I have the information for COVID vaccination centers in city A. Now I want to see the pattern where the COVID vaccination centers are, and based on that I identify that okay, the COVID vaccinations are administered not only in the hospitals but also in the PHCs, also in the clinics, and even in the schools and universities. Now with this model I can replicate this information to a new location, and that new location so far was administering, let's say, vaccination only in the hospitals, so it has an option to administer probably in schools, universities, and so on. So I can apply one spatial information that I have here to a new set of information, and the similar results can be expected there. Also, we can have a shared code. Shared code means it's very simple. I have cities in my first table. I have cities A, B, C, D. Against the city, in the first table, I have the population, I have the density. Now I have another table with the city ABC. So in simple terms, I can say I am maintaining two Excel sheets. One with the population density and all demographic characteristics. The other could be, let's say, the civic facilities present in the city. So it could be drainage lines, it could be water supply, it could be the amount of households which are electrified, or so on and so forth. So I have two different tables now, but one variable is common. What is the common variable? The city ABC. Now with each city, I can have the population data which was in the first table, and in the second table, let's say it was the percentage of households electrified. Now I can combine those two Excel sheets. So what we technically do in GIS is we have a one code that is common across all Excel sheets. So across that code, I can put query for other code, and this gives me a facility either to merge those Excel sheets and bring in the queries or bring in the results, or even if they are not merged physically in the Excel sheet, when I am giving an output in the GIS, I can have a combined information that can come from both the tables integrated into one. So with the two tables, I can have, let's say, the density of households and the percentage of houses that are electrified among those population, which can be identified because I have two different sets of information, and with a shared location code, as we have called it, this shared location code helps us to merge the two different informations into a single information. Now before we proceed with GIS, we need to understand definitely the component, how GIS works. So the first is the hardware. You need to have a computing system. Definitely computing system is essential, and on that computing system you need to have a software, and this software is a GIS based software. It could be ArcGIS, it could be QGIS, which is an open source software, or any other new GIS softwares that are present. So these softwares would run only on a hardware. So first you need to have a computer system installed, and then the softwares would be required for editing, maintenance, analysis, and finally representation of the data. The next is data. If I don't have any data, both the hardware and the software are of no use. So definitely I need to have information that I would be putting into the system. Finally, I can get some result, and this information, this data would be in both forms. What forms? It would be the spatial data, which talks about the space, as well as the attribute data, the data that points out to the quality. The next is the people. Now, people are essential. If I have hardware, software, data, everything, but I do not have experts who can analyze those, this everything becomes useless. So people should be there which are resourceful people, who are probably hardware engineers, software engineers, data analysts, GIS professionals, all of them working together in order to bring out the best results. And finally, the procedure. Now, procedure is the set of methods, the step-by-step methods. So let's say I obtain a remote sensing imagery, the satellite imagery that I have obtained. Now that satellite imagery is a false color composite imagery. Also, it is an imagery where the coordinates are not mapped with the real map. So what I need to do first? I need to do it in a step-by-step procedure. I need to acquire a satellite imagery. I would actually find out the coordinates. I would map those coordinates with the existing ground base, and this can be done through ADAS Imagine is one of the softwares. Then once you have the coordinates mapped, I can identify and read the satellite imagery with the present location and say, okay, this is the area where the forest cover is there, this is the area where residential settlements are there, and so on and so forth. Now the next is understanding data. Now data format, as we know, can be broadly classified into two forms. Those are the raster data and the vector data. Raster data is usually seen in square pixels. Vector data is a line art or a line graphic. So even if you zoom it to any extent, you won't see the lines breaking. It would be a smooth continuum of lines that would be seen. However, with raster data, if you zoom the image, what would happen? It would break into such square pixels as you can see in this image, and this actually explains how the things would be represented. Now, as we understand, raster data is basically small square pixels, as we said. So these could be arranged in rows and columns. So vertical ones as columns, horizontal ones as rows. Now these columns and rows, there would be set of cells. So we call these as grid cells and the complete one as the grid. Now each of the grid would represent, each of the grid cell would represent the individual pixel, and this shows the relationship between the size of the cell and the number of the cells. So the same shape I have here. Now what I can do is I can just double the number of the rows and the columns. So each of those I can again divide into 4, and I can have much finer cells that can be present. So the cell size is important. So here, let's say I have a location. Now this location could be explained on a bigger set of pixels or a smaller set of pixels, and this explains the raster format. So in the first case it is just 320 pixels, but in the second case it is 1440 pixels. So this explains a better resolution. The second case explains a better resolution because if I am zooming it, it is breaking down into smaller pixels, and therefore the readability is much better. That is the basic idea behind a raster image. So digital representations, it can be in the form of photographs, aerial photographs, satellite imageries, scanned paper maps. All of those are in the raster format. When the cost needs to be kept down, we usually use raster format. Very important. The next is maps usually do not analyze the individual map features, and when a backdrop map is required which can be overlaid on this, we require a raster map which can have finer details and information about different units and different places. The next is a vector map. Now here it is the same representation but with a line art. So the coordinates with the starting point and the end point are simply recorded with a line. Now since they are recorded with line, they can be zoomed to any extent and these won't actually break. The lines would remain lines, they won't break into square grids, and therefore vector art is highly precise in information. The information is very precise. The file size is relatively smaller as compared to raster files, and therefore a lot of vector data can be stored onto the computer with lesser computer space only, and greater analysis, greater in-depth analysis can be provided. So here is a quick comparison of each of the vector identities and their corresponding raster identities. So let's say I have the points of hotels. In the vector identity, I would mark them as these locations, but in a raster, these would look something like that. Similarly, if there is a forest area, this would be a vector location, this would be a raster location, and so on and so forth. So these examples are just there to cite how different a raster data looks from a vector data. Now, definitely both of them have their advantages and disadvantages. First, move on to the raster, understanding their benefits and drawbacks, then we'll move on to vector. So raster data, as we said, keeps your cost down. First of all, it gives you information in pictorial form. Simple data can be explained. Data is much more detailed and comprehensive. It is compatible with the imageries and the satellite data or the aerial photograph data, and same grids can actually explain various different attributes. However, there are disadvantages associated to it. The first disadvantage is it is insufficient to use. The storage required is very higher, so you need to have better storage devices. Also, there are lots and lots of errors. Why? Because every data is stored in pixel form. So if my line goes somewhere in between these two, there has an error. It has an error, and this is the error that I can mark. So definitely the raster data has elements of error. The preciseness is less as compared to a vector data, and also if my grids are large or my resolution is low, simply put, what would happen? There is a lot of loss of data, and this can be removed easily through vector data. So vector data much more compatible, much more compact, requires lesser space, much more efficient in form of projection transformations that are required. More accurate map outputs can be obtained with vector data, but this is not just it. Vector data comes with its own drawbacks. The most important drawback is a difficult overlay operation. For example, I have one vector data and the line art for the same, the second vector data and the line art for them. Now if I want to overlay two, first one is in, let's say, black color, the second one is again in black color, so it becomes very difficult. So first one if is in black color and the second one is in brown color, the third one is in green color, and there is a line or there is a portion that overlaps, it becomes difficult to identify. However, that is not so difficult in case of a raster image. So vector data do come with their limitations, and moreover they are not compatible with satellite imageries and therefore not practically used. So with satellite imagery, so you need to have satellite imageries that first need to be mapped with the basic coordinates and then finally assessed for future analysis. Now, what is the sequence? The sequence first of all is we understand the spatial data, the pure location, the coordinates that we need to understand. Then we enter the attribute data to it. Once we enter and attach the attribute data to the spatial data, we start editing the data. We need to verify the data. Sometimes there can be error in the entry of the data. There can be extra zeros, less entry, incorrect entry. So all those data verification and entry needs to be checked. And then finally we link the two attributes, the spatial attribute and the spatial data and the attribute data through the simple linkage. As we gave a very simple example, we identify each of the locations, we give them a code 1, 2, 3, 4, and with that 1, 2, 3, 4 code, we mark the various parameters or the attributes, and then we link those two. Finally, we put it on the map and represent it. Now, this representation could be through various color shadings, various patterns, or any other method that we can find useful. Now, of these 5 things that we have understood, the spatial input, entering the data, verification, linkage and analysis, we would start with each of those one by one. So the first thing that we understand is data input. How do we input the data? How do we input our data into a computer? If I need to input numbers, I would type the numbers. If I need to input a map that I already have, probably I'll scan the map and upload the map. I can also digitize the map that is actually present and scanned and uploaded. So there are various ways under which you can input the data. Inputting the normal attribute data is easier task. You have the values, you have to simply put it into the sheet. But when it comes to spatial data, first of all, we need to acquire it in the digital format, or if it is not in the digital format, we need to create a digital data set for it. So if I have a physical map of a place, I'll have to scan it, upload it and then digitize it. Once it is digitized, digitization means, let's say this is the map that I have. Now this map I would actually mark on various locations. So I mark down the various locations and the area corresponding to it. Now this area I would map with a real ground image that exists onto the ground, and this is how digitization works. So each mountain, each river would be digitized. So the Survey of India provides the topo sheet for India, various regions of India, and those topo sheets need to be digitized in order to bring in or overlay any other satellite image data. So acquiring data, what is important? First of all, the data, how big it is, how vast it is, the scale of the data, whether the data is georeferenced. Georeferenced means the latitudes and the longitudes are matched. So whatever is scanning I am doing for a map, I need to georeference that map with the original map that is there. So the latitudes and the longitudes must match. If it is not matching, what would happen? The well which was to be in the north would come in the south or probably somewhere else, because the coordinates are not correctly matched. So coordinates should be matched, exact overlapping should be done. Data collection techniques become very important. The quality of data that you need to understand becomes important, and then you further need to classify the data and create a digital data set. Now when you are creating a digital data set, you would be entering all the necessary information. Now this could be in two forms. It can be CCD scanners or CIS scanners. CCD are charge coupled devices and CIS is contact image sensors. Now contact image sensors are also known as flatbed scanners, and these flatbed scanners usually have a kind of lens, as you can see here, and the LED, and it moves with a photoreceptor onto it. So you have a scanning direction that is followed. However, in a CCD scanner, which is a charged coupled device, you have a ray of light or the light that is emitted from a source, and then you have a scanning direction which is followed. So there is a mirror on the top through which you have the scanner that moves. So in the scanner, usually light emitting devices are used. These could be fluorescent lamps and a digital camera with high resolution lamp is usually part of it. It is equipped with special sensors, for example the charge coupled devices, and they are basically arranged in a specific pattern, and when they are scanning, they are providing digital value to each of the points that is being scanned, and finally the input that you are providing appears as the same output on the computer screen. So this is how scanners work. So scanners record the data into a step-by-step process. So if you have seen someone actively scanning, let's say a sheet of paper, what would happen? Let's say this is the image that has to be scanned. If the scanner starts from this point, you would see this white section first, and then you would see the purple section later. And it appears as a step-by-step process where this pen, if consider this to be a flat pen that is to be scanned, this flat sheet, it would first have the white imprint on the screen, on the computer screen, when you would see the scanning results as an output, and then this slowly increases with the purple strip. And this is how scanners work. So it first of all scans the document all at one go, and when it is reading it, it is visualizing it, it is in a step-by-step process that you can see. Now as we said, these types of scanners are important and they help in understanding the basics. The next, as we understand, after the data input is entering the attribute data. Entering the attribute data could be in the form of data location, symbols, colors, indicators. If I am talking about road building in an area, if it is part of a government project where you are supposed to develop a 4-lane or a 3-lane road or a pakka road into a village, what would be the scenario? You would understand what is the road width, what type of material has to be used, what is the estimated number of traffic that would be flowing from this region, whether you require crossroad or a traffic light in between. So all this data is what? This is nothing but an attribute data. This attribute data would be overlaid with the actual information, and then you would have the results that would be seen, and then we verify the data. Verification, as we mentioned before, there are various processes. First is whether the data is incomplete. A person who was entering the data entered half of it, went for lunch, forgot to enter the remaining. So if there is any incomplete data, if the scale is incorrect, the scale at which I am entering the data and the original scale that has to be entered, or there are certain distortions. Even the spatial data that you enter can have distortions. There can be a difference in the scale. So the scanned image and the original base map can have different scale. If they are on the different scale, I cannot map those. I cannot do a georeferencing. If there is distortions, then again there would be a problem that can be seen. So data accuracy is very important. This data accuracy is both for the attribute data as well as the spatial data. So how you plot it, how you explain it becomes important. So let's take a very simple example. You have a table. Now on this table there is a light source coming from below. So you have the first map that is there. Now based on this map, you are plotting another map, as you can see. Now when the another map is being plotted, what we need to understand is any extra areas are being marked, any important areas which have to be marked are left. So all those information are part of distortion. So distortion is very, very important to understand. Digitization helps us understand that random distortions can be there. Random distortions can be there. Let's say if there is aerial photograph that is being obtained, but there was huge exposure of sunlight, or there was rain or cloud, because of which the data is not clear, the data is hazy. So there can be distortions. The extreme boundaries are not visible. So there can be distortions because of some reasons, and we need to understand it carefully. The next is connecting the data. Spatial data, attribute data. How you connect it? 4 simple methods: linkage, exact matching, fuzzy matching, and hierarchical matching. How do we understand it? Linkage is very, very simple. I have 10 states. Within the 10 states, we have, let's assume, the mortality rate within each of the state under 10 years of age. So that is what is linkage. In the first table, I have the number of children in that age group. In the second table, I have the information on mortality under 10 because of malnutrition, and then I link the 2 files, and this is what is linkage. And then I say, with this much population there is this much mortality in this state, with this much population the mortality rate is higher or lower in another state, and this is a simple linkage. So linkage gives you or establishes a relation between, let's assume, a population as one of the indicators, and mortality rate among children because of malnutrition could be one of the examples as another indicator, and you simply link it. Exact matching means you are matching the phenomena exactly. So another simple example, I have information in one computer system and my friend is doing analysis in another computer system. Now the same computer, the same city names are extracted in my system and his system. So what I can do is I can bring a exact matching. An exact matching can be done when the names or the indicators are exactly same. So my towns are ABC and my friend's towns are ABC. In that scenario, I can merge that 2 information, and this would be an example of exact matching. The data can be joined. So if let's say it's a big project, okay, we are trying to do some survey of any of the locality XYZ. I collect 20 parameters of information. My 3 other friends collect different 20 parameters. So the work is saved with all of us. Now with exact matching, I can join this all data. So my 20 parameters, the 20, all 80 parameters can be joined into one section, and that can be done only when there is exact matching. And this exact matching can occur when you have the exact spatial location or a common indicator across which you are matching. So my georeferenced map and their georeferenced maps in simple terms should be the same. Only when the latitude, longitude, scale and all other things that we have discussed so far remains uniform, I can proceed with the exact matching. The next is hierarchical matching. Hierarchical matching, further simpler. What happens? I have a land use data and my land use data is for a large area. So that information I can collect very, very quickly, probably every 10 days, every 15 days. I can collect an information about the land use pattern, the agriculture, the kind of barren land, the wasteland which is present. But there is land transformation which is going into small pockets into that area. So probably I am bringing in new technology, smart agriculture, agri-tech setups, new startups in agriculture, 3 different locations. Not in the whole area. The whole area I am analyzing every fortnightly, every 15 days. Now these new things that are being established as part of the bigger unit are located at 3 different places. So I have the information from these 3 different places probably once in every 2 months or once in every 3 months, but that's fine. I have a hierarchical matching. The bigger area, which is the total area, is already there, and from that I am seeing the impact. Let's say in the total area agricultural production was so and so. With the smaller area where I did a hierarchical matching, I saw that the agricultural production has increased 20% because of smart agriculture. In the other region where agri startups were there, the agricultural production increased 5%. So then I can relate the data through the hierarchical matching and find out which technique is much more feasible in this area and what kind of agricultural revolutions or changes can be brought in this area. And this is how we do a simple hierarchical matching. So this was an example of hierarchical matching. The last is a fuzzy matching. What happens in a fuzzy matching? In a fuzzy matching, we usually have boundaries, but that boundaries are not well clearly defined. For example, I can have forest boundaries, I can have crop area boundaries. So even within one parcel of the land, let's say this is a farmer A who has one parcel of land. He grows crops, let's say groundnut and maize and wheat. Now this is the region for groundnut, this is the region for wheat, and this is the region for maize. But the boundaries are not exact. They are hazy. A little maize can go in the region of wheat, a little wheat can come into the region of maize. So I have hazy boundaries, no exact boundaries, and this is where we do fuzzy matching. So we have a tentative boundary in mind, and based on that tentative boundary in mind, we are trying to relate two different phenomena. So I have the crop boundaries and similarly I have the soil boundaries. I do not have exact soil boundaries for this region. So again the soil boundaries are what? They are probable boundaries. So probably this is the region where you would have the red soil, black soil and so on. Now when I am overlaying these two areas, this is what is known as fuzzy matching. One important thing with fuzzy matching is the boundaries of a small area do not match with the larger ones, and this occurs mainly when environmental data is taken into account. So with GIS we have these following four basic types of linkages and matching that can be done. The last one is analysis. Now how do we analyze the data? We have done so much so far. Now the final thing is analyzing and representation on the map. So when I am analyzing and representing it on the map, what are the various ways through which it can be done? Again, four simple methods. It can be overlay analysis, buffer analysis, network analysis and digital terrain model. What are those? We'll understand in a while. But the idea here is to predict the future trend, to predict the changes with time, the changes in the variety, the changes in the phenomena. We need to have a step-by-step procedure, and this procedure is obtained through this spatial analysis. The first one is overlay analysis. Very simple, very explicit. I did a study on urban land use. I did the study on urban land use probably in 1990. Then probably my next student did the same study in 2020. Now, what are these two studies? These two studies are the urban land use of a region A. Now, when I mark the urban region A with, let's say, agriculture here, industry here and residential patterns here, my student who did the same research after 30 years, probably not true as of now, but yes, let's take this as an example. But yes, if it is 30 years down the lane, what would happen? The agriculture area has confined, okay, the industrial region has expanded and the residential area has confined. So I can overlap the two maps and explain how the urban sprawl is taking place. What is the direction in which the agriculture is reducing or where the industries are expanding? So I found out this was the region where industries got established, and this indicates the pattern of urban sprawl or urban development, how it proceeded further. So this is a overlay analysis, one time frame with another time frame. It could be based on time frame, it could be based on any other parameter that could be taken into analysis. The next is buffer analysis. Buffer analysis means near a certain place, what is a specified distance around that place. For example, I have a well, a tube well in a village. I say people within the radius of 500 meters can get water from this well. So this becomes my buffer. So this well and a 500 meter radius Across it is the buffer area. These are the people which can be served with this well. Assume I have another well here, again with 500-meter radius, and this is the region which can be served with this well. Now, listen carefully. I have a third well here with a region of 1 kilometer radius, a bigger well with more water. It can serve a region which is this much. Now, there is a overlap that can be seen, as you can see here. So, a person lying at this location probably could have an advantage of going to either of the wells. A well which provides 1 kilometer, which can drain to 1 kilometer or provide water to people up to 1 kilometer, and another well which was within the 500-meter radius. So, this person probably has an advantage of both the wells, and this is what we help or we find out through a buffer analysis or a buffer operation. So, we generate polygon features. It could be on all the three features. It can be on the point feature, as we said. It can be on the line feature. I have a transport network here. This is the transport artery. Across the transport artery, this is the population that can be served. And if it is an aerial feature, probably I have the river and the watershed drainage across the river. So within that watershed, what all features can be seen, or if it is a forest area, what is the buffer area across forest where the wildlife could be seen. And this is an example of buffer analysis. So all these actually explain up to what specified certain distance, certain things can happen and certain things can be explained. The next is a network analysis. Network analysis is an analysis where we say, let's talk about a new location or a new hospital that has been built. What are the networks that connect to that? It could be straightly from the highway. It could be close to a metro location. It could be close to a railway line. So, how networks are connected and how better network connectivity is there, traffic flow can be analyzed. The next is a digital terrain model. Digital terrain model helps us to analyze what kind of physical relief features are present, whether it is a low-lying area, a hilly area, a plateau area, and based on the area, what kind of activities are present can be further analyzed. So, all of those are some of the ways through which spatial analysis can be done. More details on each of those we would be understanding in separate lectures as we proceed with higher learning in GIS. So this was just a very introductory class on what is GIS, why it is important, what is the sequence of GIS and how this process runs, what is the importance of linkage and matching, and finally once the linkage and matching is done, the analysis is done, and this analysis is visually represented on the map, and this becomes a graphic picture which is much more simpler and easier to read and comprehend. Computers and software technologies are essential for those, and therefore we call this as a part of spatial information technology or integrated or amalgamation of GIS, GPS, digital cartography and database management systems to understand the spatial information technology. We would be covering many more interesting lectures in geography and GIS. Stay tuned for updates from our side. Have a wonderful day ahead.